In this video I'm going to go over C4 trig identities. Let's start by writing down what they are. First we've got sin theta over cos theta is tan theta, and it's an identity that we've got equivalent sign and we're suggesting it's valid for all values of theta. And then we've got sin squared theta plus cos squared theta equals 1, and these two identities are in fact given in the formula booklet. The ones that we should memorize are tan squared theta plus 1 is sec squared theta, and 1 plus cot squared theta is cos sec squared theta. So these ones are not given. I'm just going to run through one or two examples on how these can be applied. So we've got a triangle ABC where A is 90 degrees, cosec B is 2. We're going to find values of B and C. So cosec B really just means, or implies, that the sine of B is going to be a half, since cosec B is 1 over the sine of B, and we're saying this equals 2, so therefore sine B is a half. And if sine B is a half, then we know B equals 30 degrees. If B equals 30 degrees and A is 90, that gives us 120. Then we know that angle C has to be equal to 180, take away 90 plus 30, which gives us 60 degrees. Now the tan of C and the sec of C, well, once we know what C is, so that's quite straightforward, because the tan of C is just going to be the tan of 60, and that gives us square root of 3, and the sec of C is 1 over the cos of C, which is 1 over 60, 1 over the cos of 60 would simply be equal to a half, and so that gives us 2. So the sec of C is equal to 2. So the last part of the question, where you've got tan squared C plus 1 is equal to sec squared C. Well, the left hand side, we're going to show they're equal. The left hand side is tan squared C plus 1, and we know tan squared C, where C is 60, is square root of 3 squared plus 1, which is 3 plus 1, which gives us 4, and this equals to the right hand side, which is sec squared, go up, sec squared C. So we've got sec squared C, which is really just 2 squared from here. We can see that from here, this value here. So therefore this equals 4. So the left hand side does in fact equal the right hand side. Make that a bit bigger. And we've met similar cases in C2 trigonometry, and in order to solve this, so we've got a sine and we've got a tan, and we're going to find theta in between minus 180 and 180. In order to solve this, we need it to either be in all of sines or all of tans. And if we go back to our first page, we actually have our identity which relates the sine, 1 over sine squared, and 1 over tan squared is 1. That relates the sine squared with the tan squared, and then we can use that over here. So we've got that 1 plus cot squared theta is equivalent to cosec squared theta. Then we know that our cosec squared theta equals 3 plus cot theta. Let me just highlight that. So here we've got an identity. And we know cosec equals 3 plus cot. That's what's given to us. But we also know this equals 1 plus cot squared theta. Cot squared theta minus cot theta, take away take away 2 equals 0, and that 2 is really from the 1 take away the 3. We can see now it's in the form where we've got a tan, 1 over tan, 1 over tan, and 2. And so we can do a little trick and just say let x equals cot theta, and so we've got x squared take away x take away 2 equals 0. We can now factorize this and solve it, so we should get x minus 2 and x plus 1 equals 0. And so we've got x equals 2 or x equals minus 1, and that gives us cot theta is therefore equal to 2 or cot theta equals to minus 1 with, let me just bring this down here. So with the cot theta equals 2, this will give us 1 over the tan theta equals 2, and so tan theta equals a half, and we get theta being equal to 26.6 degrees. Similarly, cot theta equals minus 1, we have 1 over tan theta, and this equals to minus 1. And so tan theta equals minus 1, that gives us theta equals minus 45 degrees. So since tan theta has a period of 180, other solutions can be found by subtracting 180 to these values here. So we can do theta 3 equals 26.6 take away 180, which gives us minus 153.4, or theta 4 equals minus 45. If we subtract 180, obviously it goes over, but we can add 180, and that gives us 135 degrees. So therefore our theta values are going to be minus 153.4 minus 45, 26.6, 135 degrees.